So we all know that a monomial is just a term that has a number and a variable with it. So we can have 5x squared. We can also just have an x, and we can have a monomial that has multiple variables in it. So we can have a 3x cubed y squared. These are all individually called monomials. So in a monomial, the term that's in the front, the number, is called our coefficient. That's our number that we're multiplying by the variable. So in this instance, it's the 5. Here, it's an understood 1. And here, it's our 3. So our coefficient is always just the number that's going to be out in front that's multiplied by our variable. Then our degree is the exponent of the variable. So it's going to be 2 in this instance. Here is another understood 1. And then here it's our 3 and our 2. And when we have a monomial that has multiple variables in it, we add together the exponents to get our degree. So the degree of this monomial is going to be 3 plus 2, since it's our 3 from our x and our 2 from our y. So our degree is going to be 5. So our coefficient is the number that's out in front multiplied by the variable, and our degree is the exponent that's on the variable. So now that we have our coefficient and our degree, when we combine polynomials, we call it, or when we combine monomials, sorry, we call it a polynomial. So if I were to write 2x to the 5th plus 5x cubed plus x squared plus 8. This is going to be a polynomial because it's a combination of individual monomials. And when we write a polynomial, we want it to be our standard form. Standard form is going to be with our highest degree to the lowest degree. And our 8 is going to have an understood x to the 0. It doesn't have any x values. So that's going to be last. Our individual numbers, our integers, are always going to be at the end of our standard form. So our monomials are ordered from largest to smallest of degree. So we're looking at the 5, the 3, the 2, and the 0 in this case. So we're listing them from greatest to least, and that's how our standard form goes. Then once we have our standard form of our equation, our leading coefficient is going to be the number that is linked to the first term. So in this case, it's going to be our 2. Even though our 5 and the 8 are larger than 2, they aren't linked to that first term in the polynomial. So that's why this 2 is called our leading coefficient. It's the coefficient that's at the beginning of the polynomial. So now that we have our definitions, let's move on to adding and subtracting polynomials. So when we add and subtract, we're going to be combining like terms. And what I mean by like terms is a term or a polynomial that has the same degree. So if we have an x squared and a 2x squared and a 3x squared, we're combining those because they have the like term of x squared. So let's say we wanted to add x squared minus x plus 1. So this is one polynomial right here. I want to add this polynomial to 4x cubed plus 3x squared plus 2x. So when I'm adding these together, I can either point out which ones have the same terms or the same exponents. So I can either say, okay, so I've got, where are my x squareds? I have an x squared here, I have an x squared here, and that's it for the x squareds. Then I have an x cubed here. I only have one of those. And then I have an x and an x. So then I can go that way and I can just combine them kind of in my head and write it out in standard form. Or I can put these on top of each other. So I can make kind of like a long addition problem. So I have 2x squared minus x plus 1 plus 4x cubed plus 3x squared plus 2x. And when I line these up, it's not really that easy for me to add them just straight down if I don't line up my terms. So instead of this, actually I'm going to erase this. I'm going to change my bottom problem to line up better with my top one. So I have a 4x cubed, which I don't have in this top problem, so I'm going to add a 0x cubed here just as a placeholder. Then I'm going to put my 4x cubed here. Then I have a 3x squared. I'll line that up with the 2x squared. Then I have a 2x, so plus 2x. And then I don't have any numbers without exponents, so or without variables, so I'm just going to put a 0 as a placeholder here. So now I can just add straight down. So I've got 0 plus 4 is 4x cubed. So I need to make sure to always bring down that variable with it. I'm just combining the coefficients because I have 0x cubes here and I have 4x cubes here. So I end up with 4x cubes. Then I have 2x squareds and I want to add 3x squareds to it. So I have 3 plus 2 is 5x squared plus, then I have negative 1 plus 2 is going to be positive 1x, and then I have 1 plus 0, which is 1. So that's how we add polynomials together. We just combine the like terms. So I'm going to say over here, combine like terms. And that's the strategy that we're also going to use in subtraction. So let's try a subtraction problem. So when we're doing subtraction, we want to pay attention closely to parentheses. And when we have our subtraction sign in the middle, we want to distribute our subtraction sign. So I'll show you in a second here how that's going to look. Okay. So let's say we want to subtract 5x cubed minus 7x squared plus 3x minus 4. So this is our first polynomial. Then we're going to subtract from that 8x cubed plus 2x squared plus 3x minus 7. So a good way to think about these problems, we can either do it that linear way like we did with addition, or we can distribute this x right from the beginning and rewrite our entire expression so that it's easier to kind of see where we're adding and subtracting. So I'm going to just rewrite this half. So 5x cubed minus 7x squared plus 3x minus 4. Then I'm subtracting this whole function here. This is going to be one unit that I'm subtracting. So I want to distribute this minus to each term. Because I'm subtracting an 8x cubed, I'm subtracting a 2x cubed squared, and I'm subtracting a 3x, and so on. So I'm going to say minus 8x squared, cubed, sorry, minus 2x squared, minus 3x, and I have a minus, so that turns into a plus 7. So now I can just combine all my like terms. So I have a x cubed here and x cubed here. So 5 minus 8 is going to be negative 3 x cubed. Then my x squareds, I have negative 7x squared and I have a negative 2x squared. So negative 7 minus 2 is going to be negative 9x squared. Then we have our plain old x's. We have a 3x here, 3x here. And since I have plus 3 minus 3, it's going to cancel. So I have essentially 0x, which this can go away after I simplify. Then I have my integers. So I have negative 4 plus 7, which is going to be plus 3. So then I can simplify this, take out that 0, and I'm going to be left with negative 3x cubed minus 9x squared plus 3. And that's going to be my solution to my subtraction problem. So that's how we subtract our polynomials. And we're still combining like terms just like we did in addition, but this time you just have to be more careful about your subtraction sign and making sure that you're distributing it to all of the terms in the second polynomial. So now let's try a multiplication problem. Okay. So in multiplication, we are using what's called distribution, which I'm sure you guys have heard before, but we'll just go over it again. So I'll just use a simple example first. So let's do 3x times 4x squared minus 7x plus 2. So this is our polynomial. This is what we want to multiply by our polynomial. We want to multiply 3x times this whole thing as one unit. So what I'm going to do is I'm going to need to distribute this 3x to every term inside the polynomial. So, because we remember that this is one term, this is one term, and this is one term. So I want to make sure that this 3x gets distributed to each part. So when I do that, I'm just going to take it one step at a time. So I have 3x times 4x squared. So I'll write that out, 3x times 4x squared. And when we multiply these polynomials, we want to multiply with these numbers first. So we've got 3 times 4, which is 12. And then x times x squared. When we multiply variables together, we add their exponents. Because we're essentially saying this is going to be x times x squared, which is also 12 times x times x times x. So we have 3 x's, so we can just simplify that to 12x cubed, which is the same as saying 2 plus this understood 1. So when we multiply individual polynomials together, we multiply the coefficients, and then we add the exponents of the variables. So I have my 12x cubed, then I'm going to multiply, I'll write it in a different color, 3x times negative 7x. So I need to make sure to keep my signs with my terms when I'm multiplying them to the outside. So I have 3 times negative 7, which is negative 21, then an x here and an x here, so I have 2x squared, because I'm adding their exponents, their understood exponents of 1. So down here I've got minus 21x squared. Then we can do the last part, so I have 3x times 2. So I have my 3x times my 2. So then I just multiply 2 times 3 is 6, and then I don't have any x's here, so it's just going to be 6x. That's just going to be the simplified form. So then I'm adding 6x to the bottom here.